So very good morning to all. So I welcome all the learners for this flow control techniques in order to learn about the flow control techniques in computer networking. And now let us, before we go for discussion about the flow control techniques, and we may have already discussed about the different kinds of layering concept what we are using in a YSI model. So there are 7 layers are there in the YSI model. So let us have a recollect the name of the layers in a YSI model. Physical layer, data link layer, network layer, then transport layer, session layer, presentation layer, and application layer. So in this data link layer, from where the flow control techniques we are going to apply. So that is a data link control. That is a data link layer. The flow control techniques we are going to use, we are going to apply the various kind of flow control mechanisms in this data link layer. So what is the main objective of this data link layer is in order to do the reliable communications between the sender and receiver. So while we are sending all the packets of informations, data frames of informations from sender to receiver through the transmission medium or physical layer, it should be reliable. There is no losses is happen. So how the data communication is happen? Whether it will be happen at the same time or otherwise simultaneously or otherwise not simultaneously. So based on that particular concept, we have divided into two different modes of communication is happen. The one is a half duplex transmission mode and the second one is a full duplex transmission mode. So half duplex, it denotes that one device, either only one device can transmit the data at a time. So for example, if you have a device A and B, at a time, only one device can involve in a data transmission. Then we can call it as it's a half duplex communications or transmission. Instead of which, if both the devices, device A and B, they are involving in a data communications, then we can call it as there is a full duplex communications. There is a one device may involve in a data transmission and the device may also involve in a data communications. Then automatically what will be happen? There is a possibility to happen the losses. That's a collision is happen. Possibility of happening the collision. So such a kind of collisions have to be avoided. So for that purpose, CSMA CD, CSMA CA mechanisms, carrier sense, multiple access, collision detection, and carrier sense multiple access collision avoidance mechanisms is also available. So let us discuss in the upcoming videos. So now we can have enough discuss about the different modes of data transmissions. Okay. So data link layer, it is responsible for providing the coordination among the various devices. So that is very, very essential. The main objective is to avoid the collisions. Okay. Now let us discuss about what is the functions of the data link layer. Yeah, data link control. So the first one is a line discipline. So from this diagram, you can see that there are two stations are there, station 1 and 2. So here, if station 1, it wants to transfer some kind of packets from station 1 to 2, then it has to send the inquiry message. It has to send the inquiry message to the another station. It wants to know that whether the receiver, the station 2 is available to receive my data or not. That's why only it will send the inquiry message to the station 2. If the station 2 is available, no, okay, I am free now. If you have any kind of packets to send means you can send it. Then it will send the acknowledgement to the station 1. That is a connection establishment. We can call it as a connection establishment. That's a mutual understanding between the station 1 and 2 in order to involve in a packet communications. Then the station 1 will involve in a data frame transmission. Original data is transmitted from sender to receiver, station 1 to 2. Then after successful receiving the original data frame, it will send the acknowledgement to the receiver, sender. Then likewise it goes on. each and every data frames we are sending from station 1 to station 2, or otherwise node 1 to node 2, or otherwise we can say that sender to receiver. Once all the data frames have been transmitted, have been shared in between the two stations, the sender will send the EOT, that is the end of transmission. So it denotes that the entire packet transmission is over. So that is a thing. So that is if the response is inquiry from the beginning itself, if the inquiry is negative, then the sender will disconnect and restart the transmission in another time. So that is the inquiry. It may be no acknowledgement, or it may be a no acknowledgement. It may be positive or negative. If it is positive, then you can send the data frames successfully or sequentially, or otherwise if it is not acknowledged by the center 2 station 2 means, then it will stop the data frame transmission, and later on it will involve in a packet flow. Yeah, so that is only one thing. Now let us move on to the next one, that is a poll. So what is meant by polling? So poll, it denotes that it confirms that whether do you have any other data to send or not. So that's why that is the actual core idea behind that. So poll mode is responsible for when the primary device, it wants to receive some data from secondary device, then it will set the poll mode. So the primary device wants to receive the data, then it asks each devices whether you can have any other data to send or not. If it is having, so this is similar to the classroom. If the staff or faculty, if they are asking some question, do you have any kind of questions to ask? Then if the students or learner, they can have some kind of queries, then they will raise their hand and then they will ask the question. If they don't have any kind of questions, then they will simply sit. So similar to that, it will ask the poll message to all the nodes. If any kind of nodes can have a data, or station can have any kind of data, and it can involve in a transmission, or otherwise it won't involve in a transmission. And the secondary node can send more than one frames, one after the another, or sometimes it may be required to send acknowledgement before sending each one. That is a sending of acknowledgement may be happen in each and every data frames, or otherwise it may be combined together. It may be acknowledgement may be transferred to the group of successful data frame communication. Okay, there are two possibilities are there. So now you can see that there will be a pictorial representation. By compared to the theoretical explanation, you can easily understand. So that's why only you have given that. So here this one is a primary device, and there are 3 secondary device you can have. So here in this 3 secondary device, how the communications will be happen. So primary device, initially it will send the poll message to a secondary device A. If it is, so here it sends a no acknowledgement. So it denotes that the secondary device is not ready to listen the primary device data. Then after that, the primary device will send the poll message to secondary device B. Now we are getting the acknowledgement. We are sending the data from the secondary B. So then after that, the acknowledgement will be sent to the receiver. So then after that, say secondary C, then the poll message will be shared to the secondary device C. Then it will send the no acknowledgement. So based on whether you can have any kind of stations can have a data, it will reply as acknowledgement. If it doesn't have any kind of data to send, then it will send the no acknowledgement. Now let us have a discussion about the brief definition about flow control. So the flow control, what is the meaning of that? So it tells about how much data and it can transmit before the data overwhelms the receiver. Okay, so that is a flow control techniques. So usually there are 2 different types of techniques, flow control techniques we are using. The one is a stop and wait ARQ techniques, and the next one is a sliding window protocol. So there will be only one difference between the stop and wait and sliding window protocol. So here the main objective is the speed of data transmission should be equal in both sender side as well as receiver side. If the receiver can have a limited speed and limited memory to store the data, then automatically there is a necessity to store the data temporarily. So that is also, so that's why only there is a possibility to use the buffer. So buffer is a temporary storage. If the transmitted data packets is very fast by compared to receiver, then some of the exceeding packets will be stored on the buffer area. Whenever we have needed, we can easily access it based on the availability of packets. So there are two different types of flow control techniques are there. One is a stop and wait protocol, and the next one is a sliding window protocol. So stop and wait denotes that each and every data frames are sent it from sender to receiver. If it is successfully received, then it will send the acknowledgement, either acknowledgement. If it is not successfully received by the receiver, it will send the no acknowledgement signal to the receiver. And after each and every transmission, successful transmission, it will send the end of transmission message frame to the receiver. So that is a stop and wait protocol. So sliding window is somewhat differ by compared to stop and wait protocol. There is only one thing is, instead of sending acknowledgement for a single data frames in the sliding window protocol, you can send the acknowledgement for multiple number of frames. Okay, so for several number of frames before getting an acknowledgement, only one acknowledgement to denote that the previous set of data frames have been successfully received. Okay, so that is a thing. So that is a single acknowledgement for multiple frames. Sliding window, we can call it as it's an imaginary window, so we cannot able to view, but we can, that is an internal process will be happened based on the that particular imaginary box. That imaginary box value, it is flexible in size. It may be shrink or otherwise it may be expanded. There is a possibility to happen. There are two things. It may be shrink or it may be expanded. So how, when it is going to be shrink, when it is going to be expanded, it will be vary with respect to either sender side or receiver side. Okay, from the sender side, if it wants to send the data frames, then it will become expanded. Once the sender device receive the acknowledgement signal from the receiver, it will become shrink. At the receiver side, it is opposite. Initially, the receiver side window is empty. Okay, receiver side window, the imaginary box is empty. Whenever the sender is sending the data frames, it will be keep it on that sliding window. Then it will later on that it will send the acknowledgement signal to the sender. So it will become expanded, or otherwise it will become shrink. Once the acknowledgement is sent, it will become shrink. Once the data frame is successfully received, then it will become expanded. Yeah, so that is the thing. So from the sender side, what we are going to do, at the receiver side, what we are going to do. So here we have given that there is a left boundary moves inward shrinking. So whenever the sender window contains n-1 number of frames, and when they are sent out, the left boundary moves inward shrinking the size of the window. For example, if the size of the window is W, if 3 frames are sent out, then the number of frames left out for the center window is W minus 3, because 3 number of frames have already transmitted. So it will become reduced. So here let us discuss with that example. So now you can see that is a imaginary box or otherwise sliding window. So here how many number of frames we can send is, there are 7 number of frames we can send it at the side. So this one is a wall of that particular window. The wall moves in the right side direction when the frame is transmitted. If I am sending the data frame 0 from window, then it will become shrink. At the same time, it has been extended one more bit value in that particular direction. It will become expanded. So this wall, this right hand side wall will become expanded. So whenever the acknowledgement is received. Okay, so that is a kind of sliding window protocol. Okay, Then at the receiver side, we are performing that contains n minus 1 number of spaces for that frames. Okay. Once the acknowledgement is sent, the receiver window expands the number of equal number of frames acknowledged. Okay. So now you can see that is a difference is that is a the wall moves to the right when the frame is received. Yeah, it will become expanded. The mouse that is the at the receiver side what will be happen. They have given this wall moves to the right when the acknowledgement is sent. So like this from the sender side and receiver side, the sliding window shrinking and expanding functions will be happen based on the successful transmission of data frames. Okay. So now the go back in ARQ, there will be only one difference is if one data frame is lost or damaged, then it will retransmit all the frames. Okay, it will retransmit all the frames. But if it is a selective repeat ARQ techniques means it will start to transfer the remaining data frames at last, which are all the data frames are last, that particular data frames will be retransmitted. இது வந்து லாஸ் ஆயிருக்கோ அது மட்டும் வந்து ரீசெண்ட் பண்ணா போதும். But in the go back and ARQ, it won't be like that. Even the data frame is reached to the receiver, it has to retransmit the same kind of data. Yeah, so that is the only one difference is that. So now there will be some set of diagrammatical representation. From that you can get a clarity about that. That's a from sender we are sending, there are 4 number of frames, data frames are there. Up to second data frame 2, we have successfully sent all the frames to the receiver. But error is happened on the data frame 2. So it will send the no acknowledgement signal to the receiver. At the same time, data frame 3 have been transmitted to the receiver. So after that, data frame 4 will also be transmitted, then data frame 2 will be reset. Okay, so that's a kind of. So here you can see that the center side there are 4 bit values are there. The size of the window is 4. At the receiver side also we can have a 4. Now we have sent the frame data frame 0 and 1 here. At this side, at the receiver side, it will become shrink, then it will become expanded. 0 1 will also be added with the data frame as a sliding window, then it will become expanded. Then after that frame 2 is sent. So that 2 acknowledgement, after getting the acknowledgement of data frame 2, your window size will become shrink. Now you can read this content. Go back and ARQ techniques. We are sending all the data frames, 4 data frames, 0 1 2 3. Then 4 data frame 4 we are sending the acknowledgement. After getting the sender sends the next frame from its buffer area, which is a frame 4, because the receiver will receive the acknowledgement for data frame 0. So that's why only the 4 is transmitted again. After that, the receiver acknowledge for 1, then it has started to send the next data frame 5. While we are sending the data frame 6, it has been lost. It has been broken or lost. Then what shall we do? Here it has started to send all the frames. That is after 2, we can have a 3, 4, 5, all the frames we are sending again, once again. Okay. just we are discarding the remaining packets. Even we have already sent the packets, once again we have to retransmit the packet. That is the only one drawback of go back and ARQ model. If there is a losses is happen, it has to restart the last packets, and consequent data frames have to be sent it once again. So there is a possibility of happening the duplications at the receiver side. Now selective repeat ARQ is somewhat differ by compared to go back and ARQ. That is the only advantage. That is the only advantage by compared to go back and ARQ method. So here initially 4 data frames we are sending from sender to receiver. Now the window size is 4. Then after getting the acknowledgement for 0, the data frame 1 will be transmitted. Then data frame 1 to 5 will be transmitted. The same kind of scenario. Here, while we are sending the acknowledgement for next data frame 5, it has been lost. So here in the go back in ARQ, what we have done means after 2, that's a 2, 3, 4, 5, we have retransmitted again. But initially, which are all the portions we have sent it already? 3 transmitted, 4 transmitted, 5 transmitted. Okay, that's the only one loss is happen is 2. Data frame 2 is lost. Okay, so அப்போ என்ன பண்ணலாம்? We have to retransmit only last packets. That's a 2. Okay, ரெண்டை மட்டும் நம்ம transmit பண்ணிட்டு அதுக்கப்புறம் 5க்கு அப்புறம் இருக்கக்கூடிய 6, 7 வந்து நம்ம transmit பண்ணிடுறோம். Okay, so clearly you have to understand. That is why you have to understand the concepts. Then if you read that content, you can get a clarity at that. Sender will not send the frames 0, 4 or 5 again. That's the main thing. And it knows that frame 2 is missing because the receiver would have sent a negative acknowledgement for frame 2. So the sender will retransmit the frame 2 alone. And as usual, other frames are transmitted. Okay, data frame 2 only we are sending. That's the only one main advantage of selective repeat ARQ method by compared to go back and ARQ method. I hope you can have a clear-cut view about the flow control techniques what we are following in a computer networking. So in this presentations, in this class, we have discussed about the what is meant by flow control and which are all the different types of flow control techniques are available, and what is the importance of flow controls, and in which layer of OSI model that flow control techniques we are applying. What is meant by stop and wait ARQ, go back and ARQ, then selective repeat ARQ method, then stop and wait ARQ method. So along with one sample examples we have done. Okay, I hope you have enjoyed this session. So thank you for watching. Thank you.